Hi everyone. In this video, we'll begin section 8.2 by learning when to use the student's t-distribution to conduct a confidence interval for a population mean. We'll also discuss the conditions required for using a t-interval, look at the confidence interval formula, and learn how to find a critical t-value using a TI-84 calculator. Let's begin. Before we begin, let's review a few important definitions. A point estimate is a single value from a sample used to estimate a population parameter. Since we are estimating a population mean, our point estimate is the sample mean, x bar. The margin of error, denoted by E, is the maximum expected difference between the sample estimate and the true population parameter. A confidence interval is a range of values used to estimate a population parameter. The confidence level, such as 90%, 95%, or 99%, tells us how confident we are that the method used to construct the interval captures the true population parameter over many repeated samples. When should we use the t-interval? This is the most important concept in this section. To decide whether to use the z-interval or t-interval, ask yourself one question. Is the population standard deviation sigma known? If the population standard deviation sigma is known, use z-interval. If the population standard deviation sigma is unknown, use t-interval. Most of the time, the population standard deviation is unknown. Instead, we use a sample standard deviation denoted by S. So whenever we use S instead of sigma, we use the student's t-distribution. Whenever we use the student's t-distribution, we need the degrees of freedom. The formula is simple. The degree of freedom is equal to n minus 1, where n is the sample size. For example, if the sample size is 20, then the degrees of freedom is 19. And as the sample size increases, the t-distribution becomes more like the standard normal distribution. Before constructing a confidence interval, we need to check the conditions. First, the sample should be random. Second, the observations should be independent. If we are sampling without replacement, the sample size should be no more than 5% of the population size. Finally, either the population is approximately normal or the sample size is at least 30. So for a t-interval, we want a random sample, independence, and either normality or large enough sample size. Now, let's take a look at the confidence interval formula. Do not worry about calculating this by hand right now. In this course, we'll mostly use the TI-84 calculator to construct confidence intervals. For now, I just want you to recognize the formula and understand what each part means. The confidence interval is x bar plus or minus e, where x bar is the sample mean or the point estimate, and e is the margin of error. You may also see the confidence interval written in the interval notation. These two forms mean the same thing. The first value, x bar minus e, is the lower bound, and the second value, x bar plus e, is the upper bound. So the lower bound is the smallest value in the interval, and the upper bound is the largest value in the interval. When you use a calculator, it will usually give the confidence interval in the interval notation form. This is the formula of the margin of error. E equals T of alpha half multiplied by S over square root of N. Here, S is the sample standard deviation. N is the sample size. And T of alpha half is the critical T value. Again, the calculator will do the calculation for us. You just need to know what the symbols represent. Notice that the formula includes T of alpha half. So our next step is to learn how to find that value. Let's work through an example. Find the critical value T of alpha half for a 99% confidence level with N equals 20. The first thing we need is the degree of freedom. For the student's T distribution, the degree of freedom is N minus 1. And N is 20, so I have 20 minus 1, which is 19. Now, before using the calculator, I recommend sketching a quick picture. Draw a bell-shaped curve. The values on this horizontal line are the T values. The value at the middle of the curve, where the peak is 0. 99% confidence level, or 0.99, is the area in the middle. So this area is 99%, or 0.99. So this value is negative T of alpha half, and this value is positive T of alpha half. The total area under the curve is 100%. So the remaining area is 1%. That 1% is split equally between the two tails. So this tail is 0.5%, and this tail is also 0.5%. And 0.5% is equivalent to 0.005. Now, we want to find T of alpha half, so we want to find this T value right here. And we are going to use the TI-84 calculator for that. So we use a function inverse T in the TI-84 calculator. And it will ask for the area to the left of the cuticle value. And the degree of freedom. So we want to find this value, and we want the area to the left of this value. So the area to the left of this value is everything to the left, including the 99% and the 0.05%. So from here, we take everything to the left, which is 0.995. And the degree of freedom is 19. Now, let's use our calculator to calculate this. To open the distribution menu, we'll press second vars. Now choose inverse T and press enter. For the area, enter the left area, which is 0.995. For the degree of freedom, enter 19. Highlight paste and press enter. Make sure this matches the one you have on paper and then press enter. This is our answer. And the question is asking for 4 decimal places. So we have 2.8609. So the critical value T of alpha half for a 99% confidence level with the sample size of 20 is approximately 2.8609.